Okay, see Lindelof videos. L'Hopital's rule. I get a lot of people asking me questions about L'Hopital's rule. I want to make sure that before we do L'Hopital's rule, that we understand that we're doing this for a reason. And what happens is sometimes we're trying to evaluate a limit, and when we evaluate the limit, it comes back as something indeterminate. And indeterminate, let's just be clear, indeterminate is when the limit comes back like 0 over 0 or infinity over infinity or something like that. And we see this and we realize there's something going on here more than what we can tell. So L'Hopital in the late 1600s came up with this rule that really works very, very well. And this is what L'Hopital came up with. L'Hopital said the limit of f of x as x goes to c, if this is true, so let's do if, and that's if and only if, so if and only if the limit as x goes to c of f of x is equal to 0, and the limit of g of x as x goes to the same c value equals 0, and the limit as x goes to c of the derivative of f of x over the derivative of g of x is L, where L is some number. Well, if all of that stuff is true, then the limit as x goes to c of f of x over g of x is this same L value. So let's take a look at what this means, but I guess I would caution you first that you have to memorize this rule. So you got to put this thing away. Once you get the rule, it's actually pretty easy to use. So let's try this on this problem here. So let's try this. So we're going to do L'Hopital, and we're going to evaluate this given limit. The limit as x goes to 0 of sine x over x. Well, if you look at that, if we evaluate that limit, we'd be taking sine of 0 over 0, right? Because x is 0, and sine of 0, of course, is 0, and 0 is 0, and this comes back as the indeterminate form. First thing I would do is I would look and see if there's anything that I could take. Are there any factors? But nothing becomes obvious to me here. So what we're going to do is this. We're going to break this thing down, and we're going to use L'Hopital's rule. So we're going to look at this function. We'll look at this function right here, and we're going to take the derivative of the top and of the bottom. The top we're going to call f of x. The bottom we're going to call g of x. So this is exactly what L'Hopital suggests that we do. He says, take the first derivative of f of x, the top function. And the top function, of course, is sine x. Well, we know that the first derivative of sine x is cosine x. So there's cosine x. L'Hopital further suggests that we take the derivative of the bottom part. So we're going to take d dx of g of x. But we can see that g of x is in the numerator, and it is this x value right here. And the first derivative of that is 1. So if we put it together the way L'Hopital suggests, we're going to take our f prime at 0 over our g prime at 0, which is cosine of 0 over 1. So there's no way to evaluate the bottom part because there's no variable there. But we do know that cosine of 0 is 1. So that comes back as 1 over 1. So now we know that the limit as x goes to 0 of sine x over x is equal to 1. This is not a proof of this. This is just an example of how this works. It is super cool. This is very, very good math. What I'm going to do now, and if you're taking the AP exam, you're not going to be able to do this, but I'm going to go ahead and check this with my calculator. So if you don't mind, I'm going to go to escape here, right? And then I'm just going to do this. I'm going to take the limit. I'm going to take the limit as x goes to 0 of, right? And we said sine x, didn't we? So sine x over x, and see what that comes out to be. And indeed, it does come out to be 1. Now, of course, if this was on the calculator portion of the exam, this would be easy and mindless work, but it's not going to be there, and you have to be able to demonstrate how that works. So L'Hopital's rule is a great way to do that. Hey, thanks for watching the video. If you have questions or comments, please let me know. And if you haven't already subscribed, please do. I appreciate it.